Okay, good morning, all of you. We shall continue our discussion on cloud computing and its applications, Module 5, Session 6. Till now, we have discussed about various vendors and their facilities available for cloud computing, how Google, Amazon provided computing services as well as Microsoft. They provide computing services, communication services, storage services, and how infrastructure as a service, platform as a service, storage as a service, and software as a service have been implemented and provided by them, along with what are the security measures they are implemented and how they are managed with various facilities provided by cloud computing providers. Now in this class, we shall now go with realistic applications available where cloud computing is essential are being discussed, which is cloud applications. As we know already, we have discussed about scientific computing, about high performance computing, about high throughput computing. Please recall all of them, which we have seen in the previous modules. As we know, for these computing power, we require large infrastructure that may not be available at our location. For that, we can go for cloud services. So when we decide about the requirement of our enterprise, about the infrastructure requirement, correspondingly, we can do some subscription to the cloud service providers and we can get that facility. Or even if you want to scale up, scale down, all these things are very easy. We can easily do that. That is the beauty of cloud provision. So let us now see realistically how these problems are being addressed, how infrastructure management is given by the cloud providers, how do they really handle workflows, how do they really handle various tasks given, how do they create virtual environment, like they need to create virtual machines, they need to provide virtualization, no? They need to provide security, they need to provide communication. All that is required for some sensitive applications. Like it may be a problem of medical field, or it may be a problem of data intensive computing, or it may be a problem where a prime number generated, large prime number generated is a scientific computing you can think of, or it may be a weather forecasting problem, or it may be a problem of sentiment analysis, the large data set where you have a large amount of data available in the social media. Do some sensitivity analysis and do it. As we know already, such data is being used for planning elections also in other countries. So wherever you feel, wherever you think that problem can be executed or handled or rendered through internet, such problems can be taken to cloud very easily. So without any extra money, extra infrastructure, extra facility, extra software, we can think of providing this facility through the cloud. As I was mentioning, even For university like ours, there are more than 200 institutions. Each institution may require software for their laboratory, whatever may be the discipline, either civil, mechanical, electrical, electronics, computer science, whichever may be where you can handle these laboratories in a virtual mode. You require some software, and through this, based on software, if you are doing some work, such things can be implemented at the server side at the university, and that can be rendered, that can be given to all the subscribers. All the institutions will be subscribers. That is also one application. Nowadays, we are handling digital era. All transactions are being done through digital mode. So again, we can also think of having this in the cloud platform. So only thing is, we should create our own cloud, put all the software in the cloud, and ask everyone to use it. How we are doing these sessions, all these sessions are being stored in the LMS, and you can access at any point of time, anywhere you are, even on the go, you are able to access this. This is what the beauty of cloud provision. When you say if there is a cloud will help you in only bottleneck of this cloud is you should have a proper internet connectivity and high-speed internet connectivity. Through that, you can easily do all such business. So we shall continue. We shall see. I think this introduction is enough to understand the importance of the applications, related to this. Okay. Now let me continue with the various applications available which they have listed. The applications what they have listed in this textbook is just, it's not limited to this. Okay. Aadhaar based authentication is also one big problem in India. Actually, 130 crore people are there. They are having a single identity. Through that, we can easily handle. So everything will be handled through this, Aadhaar. So just you type Aadhaar, all your information will be available at your fingertip. So if you want to provide that facility, because how many people will be connecting at the same time, how much infrastructure is required, even if you want to create that infrastructure, it will be very difficult to do it. You must have a high performance computing facility, you must have a hypervisor, you must have a VMware. All these facilities need to be available at one location. Instead of that, you go with cloud service provisions like Meghraj, a project launched by Government of India. That is also one of the cloud platforms. So in this way, when you are thinking about these applications, I have one more point to note here, that because I have already told you this subject is very, very important for your future life. If you are thinking you need to find any job in cloud computing, cloud related area, then please look at all the applications available here in this chapter number 10 and see which application suits you, which area of research it suits you. Then you can think of finding a job in that area, and you will have plenty of opportunity to do some work, and it is something like to improve the nation even, or to work for the world. Cloud computing is very, very important. Maybe maybe this is the final stages of our course. There wonderfully these applications have been listed and applications have been given. Let us see now. Cloud computing has gained huge popularity in industry due to its ability to host applications for which the services can be delivered to consumers rapidly at minimal cost. Scientific applications first. As you know that, it has got a huge popularity, because when you look at cloud, yes, we require it. Big data, yes, we require it. Now we are thinking of having artificial intelligence and machine learning also into this, data analytics also into this. So everything is available. How you speak to Amazon device, how will it be connected? It will be connected to internet. It's an IoT device. Okay, so that IoT device will be connected to internet. If you do not have internet, that the device will not work, but it will understand your voice. So voice based command you can give. So that is one of the important applications which Amazon has developed. Similarly, Google is there. Google Assistant is there. You can speak to your mobile phone and you can get whatever you require. How is it being executed? It is through the web, through the cloud. In the beginning, when we started discussing web programming, we were talking with the web technology and all. Now we change that. We understand that with the cloud application. There are so many scientific applications available. Scientific applications are a sector that is increasingly using cloud computing systems and technologies. Let me give you an example here. Telemedicine, telemedicine. Yesterday, we were discussing with the doctors, India has created one application called eSanjeevani OPD. All of you, I think I have sent you a link to download that and you install that application on your mobile phone so that you can do a telemedicine. You can talk to the doctors from the remote location. Because of this pandemic situation, you can use this facility, talk to the doctors. Specialist doctors will be available on the platform and they will help. How is this working? It is working through the cloud. So whatever you are studying here, it is not limited to your framework, but you think beyond this. What exactly we can do? How we can use cloud computing facility for our problem, and that can be extended to everyone so that everyone will be benefited. The immediate benefit seen by researchers and academics is the potentially infinite availability of computing resources and storage at sustainable prices compared to a complete in-house deployment. That is the beauty of cloud computing, because you with the zero cost. For instance, some of you can think of creating, an enterprise, without any extra money. You do not have money, no problem. You need to have some subscription to the cloud computing facility that can be extended to you, and then you can start working on that. You can create a startup with no money. That is the beauty of cloud computing. Cloud computing systems meet the need of different types of applications in the scientific domain. That is high performance computing applications as well as high throughput computing applications and data intensive applications. As we know already that medical field data, the medical data is enormous. So a doctor sitting at Delhi can treat a person available in Jipmar, Pondicherry. So this we have seen, live demonstration we have seen when we went for some conference on the cloud. Live demonstration they gave. That is what we are discussing here. So it is very, very easy to understand this, the facility and extension of application, so that without any extra worry, you can easily use this facility by subscribing to certain services. Okay, let us move on. The first one is healthcare, ECG analysis in the cloud. As you know, echocardiogram need to be done. Echocardiogram, that is ECG. ECG can be analyzed because ECG is a very, very important analysis for finding problem with heart. So this can be done very in a better manner, very easy, because you want to do this analysis, you require high performance computing as well as high throughput computing, which may not be possible to purchase or establish for every doctor. So they can go with a cloud service provider and they can subscribe for a particular application for a particular period, and then they can use it. Healthcare is a domain in which computer technology has found several diverse applications, from supporting the business functions to assisting scientists in developing solutions to cure diseases. An important application is the use of cloud technology to support doctors in providing more effective diagnostic processes. In this pandemic situation, the person who is coming from UK is having a problem today. In this period, we are thinking about a pandemic. Wave 2 comes because of the Britain people. So, person who is sitting at coming from UK to Delhi and then travel to Chennai can be monitored very easily now because of this. So how they are doing it? It is through the internet facility they are doing it, and through the cloud they are doing it. All your information about cloud, COVID patients data is being put on the cloud so that everyone can be able to access the data at any point of time, anywhere, any location. So that's how it is being done. Everywhere this cloud is extending its facility to a look and corner of the gamut of your places. So very easily you can understand that cloud is ultimate. You do not have anything other than this. Maybe it should be improved in a sense that you need to have even high-speed data connectivity, because nowadays we know that the government of India is extending facility of 5G network to to the remote corner of a village. If that happens, yes, based on that you can easily do lot of applications development so that everyone will be benefited. So echocardiogram analysis is done on the cloud. So let us see how it is done. The capillary development of internet connectivity and its accessibility from any device at any time. Please remember, its accessibility from any device at any time has made cloud technologies an alternative, attractive option for developing health monitoring systems. So everything you put it in the cloud. See, when we are moving, suppose you wanted to do some job, maybe you are not in the office, you wanted to do without going to office, you can do it. In the pandemic situation, how people are working, they are all working from home. How do they do it? It is because of the cloud provision. So certain things which are to be made confidential will be there in the in their enterprise. All other things can be put on the cloud so that people can start working on that. So work from home is also one of the examples you can think of. It is through the cloud only. ECG data analysis and monitoring constitute a case that naturally fits into this scenario. ECG is the electrical manifestation of the contractile activity of the heart, myocardium. This activity produces a specific waveform that is, how ECG is done. It is related to medical field. Anyway, how we are able to access this information, how to process this information, how we say it is similar to process your voice data. There is a wave, there is a signal. Similarly, here also there is a wave, there is a waveform which will be handled, verified, analyzed. This activity produces a specific waveform that is repeated over time, and that represents the heartbeat. The analysis of the shape of the ECG waveform is used to identify, and most common way to detect heart diseases. Arrhythmias, and is the most common way to detect heart diseases. Okay, cloud computing technologies allow the remote monitoring of a patient's heartbeat data analysis in minimal time, and the notification of first aid personnel and doctors should, take this data, reveal this data, potentially dangerous condition. So this way, a patient at risk can be constantly monitored without going to a hospital for ECG analysis. At the same time, doctors and first aid personnel can instantly be notified of cases that require their attention. Wearable computing devices equipped with ECG sensors constantly monitor the patient's heartbeat. So this is given in the form of the equipments are installed, placed at the patient's home, and the information will be directly transmitted from the devices which are connected to the patient and directly to the doctor. Even the patient is at the hospital, the information will be gathered and it will be transferred to the specialist. Specialist may not be available at the same place. He may be available at a different hospital. Through your computing facility, through your networking facility, through your software facility, that can be sent and it can be sent to the specialist, and specialist can easily analyze and give some treatment. Such information is transmitted to the patient's mobile device, which will eventually forward to the cloud-hosted web services for analysis. So the device will contact the mobile phone will transfer that information to the cloud will transfer that information to the doctor's server, doctor will analyze. Even this also can be done in the online mode. So this is one pictorial representation of health monitoring system hosted in the cloud. Online health monitoring system hosted on the cloud. See, you look at the right side of the picture, you are saying infrastructure as a service, platform as a service, software as a service, all are available here. So except data as a service, network as a service should be there always, because the whole picture need to be connected through the network. So network as a service is also always there. So anyway, you have a data as a service here, ECG data as a service, security also there to keep the patient's record safe. So what else you need? You have all the services available here in this demonstration. You can easily see. So mobile phone is also connected, wireless, mobile 3G or 4G, maybe 5G technology. Very recently it may come. So for 4G came, and in future 5G will also come. We will have that connectivity with that. So what is the motto behind this? Because quicker response, okay, fail-safe response, so that we can save people. That's the important feature here. You understand that. So there is a user, there is embedded Bluetooth enabled data communication processor module, and it will sense the data, and then the data is connected through the Bluetooth technology, Bluetooth connectivity, and then it is connected through wireless or mobile 3G network. It will connect to the cloud. Cloud has got IaaS, infrastructure, platform, and software as a service, along with data as a service. Along with, there is a runtime environment also, dynamically scalable runtime environment, as well as there will be security runtime is also there. All these things are executed on the basis of Amazon Web Services. There are multiple users, large number of users available. There will be millions of user requests comes to the cloud, and it will be processed. So this is a self-explanatory diagram which you can easily understand the process of health monitoring system hosted on the cloud. So similarly, eSanjeevani also you can think of providing facility and online consultation facility to the patients by the doctors. So next, we shall move on to the next problem, next application, which is related to biology, protein structure prediction. This is very much needed when in this case of pandemic situation, because people are trying to find vaccines. We need to use this facility. How much extensively? Because as per the report we got, finding a vaccine for a problem like this, a COVID problem like this, it would take at least 4 to 5 years. This time it has come within 1 year of the first identification of COVID virus. This is because of your supercomputing facility available at every place. Even in India, very shortly we may get the vaccine for our COVID problems. Okay, applications in biology often require high computing capabilities and often operate on large data set that cause extensive IO operations. So very important here, extensive IO operations. We have seen in the previous class when we were discussing with Azure Cloud, we had extra small, small, medium, large, and extra large connectivity, and the I/O performance also it was being discussed there. With the minimal requirement, I/O operations are very less. Like here, extensive I/O operations are also needed, because this is one area we are leaving out, because we are thinking about only provisions. But for doing all this, you must have a proper mechanism to read data from the database for the computing devices, so that you can do a computation very fast. Because of these requirements, biology applications have often made extensive use of supercomputing and cluster computing infrastructure. So you have a cluster computing, you have a grid computing, you have a supercomputing facility for biological applications. Reading biology is one factor. Analyzing biological problems in another factor. Computer science graduates, being computer science graduates, we are helping to do analysis of biological problems. Similar capabilities can be leveraged on demand using cloud computing technologies in a more dynamic fashion. Dynamically, you can change it. Suppose you want to have a situation where you require double the infrastructure, you can do it with no cost, with no time. Within seconds, you can change it very easily. That's how it is considered to be a dynamic fashion. If you want to procure some computing facility, you want to procure network facility, lot of procedures are there. Now without that, you can easily do. If you have a cloud computing facility, you can simply increase, you can add them very fast, you can increase your facility, thus opening new opportunities for bioinformatic applications. So bioinformatic applications, you can easily understand this. Bioinformatic application is Aadhaar based authentication, iris of the identification, thumb impression of the authentication. So quickly you can do. Even we can introduce biometric authentication for even voting. This may come in future. Protein structure prediction is a computationally intensive task that is fundamental to different types of research in the life sciences. Among these, in the design of new drugs for the treatment of diseases, the geometric structure of a protein cannot be directly inferred from the sequence of genes that compose its structure, but it is the result of complex computations aimed at defining the structure that minimizes the required energy. This task requires the investigation of a space with a massive number of states, consequently creating a large number of computations for each of these states. Okay, the computational power required for protein structure prediction can now be acquired on demand without owning a cluster or navigating the bureaucracy to get access to parallel and distributed computing facility. Cloud computing grants can access to such capability or capacity on a pay-per-use basis. That is what I was mentioning here in the previous session also. See, NEET, JEE Advanced, your CET, and all state examinations, how do they really do this? They are going for cloud computing facility. Similarly here, whenever you require high intensive computing required pay-per-use basis, you can take the capacity and then after that you can leave it out. So instead of doing lot of procedures, a lot of procedures will be there to procure any infrastructure. Not necessary. You can just take with a minimal cost. You can take the facility. After your job, you can close it. Okay, so that is the beauty of cloud computing. So in biology also we can do that. One project that investigates the use of cloud computing technologies for protein structure prediction is JIVA. JIVA is one project which has got methods for identifying the structure. It is predicting the structure. Let us see how JIVA project will take the facility of Aneka Cloud and work on that. An integrated web portal that enables scientists to offload the prediction task to a computing cloud based on Aneka. Aneka, which we have seen earlier, Aneka is a platform where you can take up infrastructure as a service, or computing facility can be extended by Aneka. So JIVA is a prediction Jiva is a prediction task that uses machine learning technique support vector machines for determining the secondary structure of proteins. These techniques translate the problem into one-off pattern recognition, where a sequence has to be classified into one of the three possible classes EHC. A popular implementation based on support vector mechanisms machines divide the pattern recognition problem into three phases: initialization, classification, and final phase. Even though these phases have to be executed in sequence, it is possible to take advantage of parallel execution, which we have seen how parallel execution can be done. If any particular task is not dependent of any other previously to be executed task, you can take them as a parallel task, you can easily do that. So where multiple classifiers are executed concurrently, so parallel computation is applied here in the Jiva application. Aneka also supports parallel execution. This creates opportunity to sensibly reduce the computation time of the prediction. The prediction algorithm is then translated into task graph that is submitted to Aneka. Once the task is completed, the middleware makes result of available for birth visualization through the portal. You can get the information. Let us see the picture. 1 minute. Let us see the picture of Jiva portal, how Jiva portal works. There are multiple users will be sending the information to the internet, and through that Jiva portal will be connected. One task, how it is being done, initial phase, classification phase, and final phase. Just to give you the glimpses of this picture, this information will be transferred to the Aneka cloud. Aneka cloud has got various computing services, various computing devices where they can easily do whatever the services to be executed. All these services can be executed by this Aneka computing facility. So here that one task is shown like this: initial phase, and then classification phase, and final phase. So you can easily understand the facility given here through the Aneka. So Jiva portal works like this: multiple users send their request to the Jiva portal. Jiva portal connects to Aneka, and they will segregate these into three different tasks, and then if there is no dependency of these tasks, these can be executed like C, D, E, F, G, H. Once B transmits the data to these can be executed in parallel. Finally, they can be concluded, and it can be combined to get a prediction in the eye. So next problem is biology. Again, gene expression data analysis for cancer diagnosis. Gene expression profiling is the measurement of the expression levels of thousands of genes at once. It is used to understand the biological process that are triggered by medical treatment at a cellular level. Together with protein structure prediction, this activity is a fundamental component of drug design, since it allows scientists to identify the effect of a scientific treatment. Another important application of gene expression profiling is cancer diagnosis and treatment. So you can easily do cancer analysis with the cloud coax task orchestra, and then that can be sent to coax task. Multiple tasks will be there, and it can be sent to Aneka cloud for analyzing the cancer analysis, and then that can be sent to the client after the analysis. You can easily increase also. You can increase the number of users, number of computing facility in accessing this information. So classification of tumor can be done with this. More accurately, classification of tumor can be done, and proper treatment can be given for the patient. Okay, this method of analysis has proven to be effective because of high performance computing, which will be adopted in Aneka platform. Aneka platform will help in analysis of this data. Okay, thank you very much. Now let me conclude this session. Now we can go for a question answer session for 5 minutes, and then we will go to the next session later.